Okay.
Let's start at the one I have up here.
Alrighty.
This is your question 13.
Yep.
I'm drawing a little picture of it, okay? In other words, the temperature goes from 10 to 125 in the time 0 to 27 seconds.
Yes.
So why does the temperature at some point in time have to be increasing at a rate of 115 degrees per 27 seconds? What theorem?
That's the extreme value theorem.
The mean value theorem.
The mean value
What
theorem.
the mean value theorem says is that if I know the average rate, well, the average rate is rise over run, right? So it's
Right.
125 minus 10 over 27. Well, that's that expression right there, 115 divided by 27. So if I know the average rate of change, the mean value theorem says that there has to be a point on that curve. And the way I've drawn it, it looks like about right there, where the tangent line to the curve has the same slope as the average rate. In other words, I cannot go from 10 degrees to 125 degrees without at some point in time changing by 115 per 27. It's kind of like saying you cannot get from here to Colorado Springs without going 30 miles an hour at some point in time. Well, no, that's not quite true. Let's say you go from here to Colorado Springs in 1 hour. Well, your average speed is 60 miles per hour, but you don't go at 60 miles per hour the whole way. You slow down, you speed up. Some places you go less, some places you go more, but there is going to be at least one spot on that trip where you go 60 miles an hour. You cannot average 60 miles an hour without going 60 miles an hour at some point. So all the value theorem says is that there is some f prime of c that's equal to f of b minus f of a all over b minus a. This expression is the average rate of change. That's my 125 minus 10 over 27. Well, what this means is that if I take the derivative of that function, whatever the function is, there has to be some point on that function where the slope of the tangent line is the same as the average rate of change. And this point right here would be that C. We don't know where it is because we don't know what the function is. They didn't tell us the function, but we know that. So the short answer here is mean value theorem. Okay, now let's go up to another one you had.
So
go ahead.
I'm just looking at this real quick.
The previous?
So how would you, so we went over this the other day.
Which one?
So you solved for the average rate of change and then you, 13.
Right, okay. Yeah, you solve for the average.
So we solve for the
average rate of change is 115 over 27, right? Rise over run.
Okay. Okay, so you set that equal. Okay, gotcha.
Says that if the average rate of change is 115 over 27, then there has to be a point between 0 and 27 where your instantaneous rate of change is the same as the average rate of change.
Okay.
Okay, that's all it says.
So there's no real, yeah, there's no real.
And we know what the average rate of change is. It's 115 over 27. So as all that problem is saying is there has to be a point there where your instantaneous rate of change is the same as your average rate of change.
Okay, good deal.
This is kind of scary because I'm seeing odd things in my graphics here. Do you see the same odd things that I'm seeing?
Yeah, like the clear.
Yeah.
Yeah, I'm seeing those too.
I've always heard that that's the first sign you got a virus, is if your graphics start going bad. I know that if I reboot my computer, those little glitches will go away. Let's look at 11.
Oh, dang.
Okay.
Okay.
11, you made a mistake in your math is all.
Okay.
I can see what you did. Okay. Even though it goes off the page here, I can see you got down to this step here. Let me circle it. And then I think what you did was factor out a minus 3 and thought you ended up with x squared plus 1, which you canceled with the bottom. Well, the top doesn't leave you.
I tried to do that, yeah.
1. The top leaves you with minus 3 times x squared minus 1.
Yes.
Which means you can't cancel anything.
So where to go now?
Well,
right.
Here's the thing, is you have extreme values wherever the derivative is 0 or undefined. That's where your extreme values occur. Because that's where your slope of the tangent line is equal to 0, right? In other words, if I have a curve like this, well, my extreme values occur there and there. Wherever the slope of the tangent line is either 0, or if I had a function like this, well, it's not defined there, but that's still a minimum. So your extreme values come where the derivative is 0 or the function is undefined. Okay?
Okay.
Well, if we look at this function, this part right here, we can tell that the denominator...
So it can only be at x equals 1 or negative 1?
Yes. In other words, the only place you're going to have an extreme value is when the numerator is 0. Because the denominator can't be 0. X squared plus 1 is always a positive number, no matter what x is.
Right.
So there's no undefined point on this first derivative, but there is a place where the numerator is equal to 0. And it's x equal plus or minus 1. Because you end up with x squared equals 1, and that means x equals plus or minus 1. So you have two extreme values. You have one at x equal minus 1 and another one at x equal 1. Now, do you know how to figure out which is the minimum and which is the maximum?
Can you go over that?
Yeah, it's the simple way is to take the second derivative. If you take, and the reason is this, let's say I have a function like that, and I take the derivative and I discover that I got an extreme value there and an extreme value there. Okay? Now, if I want to tell which is the minimum and which is the maximum, I take the second derivative. If the second derivative is negative, it's concave down and it must be a max. If the second derivative is positive, it's concave up and it must therefore be a min.
Wait, so which one's positive and which one's negative? So
goes with the concavity. If the concavity is down, it's negative. the concavity is up, it's positive. And if the concavity is down, that must mean it's a max, right? If the concavity is up, it's got to be a minimum. So you really need to figure out what the concavity is. Well, there's two tests for where the minimum is and where the maximum is. One is the second derivative test. But clearly, with this function, taking the second derivative is going to be particularly hard, right? I mean, it was hard enough taking the first derivative. You had to use the quotient rule and then combine the numerator. Well, taking the second derivative is going to be torture. There's another test to determine whether you have a minimum or a maximum. It's called the first derivative test. And what the first derivative test says is that if your slopes, notice that on my little drawing here, the slopes go plus, 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 0, minus, minus, minus. So if you go from plus slope to minus slope, you're looking at a max. At this point here, you go negative, 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 0, plus, plus, plus. So if you go from minus to plus, I'm sorry, you're looking at a minimum. And what you have to do is plug in numbers. In other words, if I know my 2 points are minus 1 and plus 1, well, if I want to know what the slopes are about the minus 1 point, let's say that's minus 1, well, I could plug in minus 2, and if I get positive slopes, and then if I plug in 0 and get negative slopes, that means that's a maximum. And that's probably the easiest thing to do here. Because it's such a tough function to differentiate twice, if I plug in minus 2, I get negatives, right?
Yeah.
In other words, I know that I've got an extreme value at minus 1 and plus 1. So if I want to know what's going on at minus 1, I'm going to plug in minus 2 into the derivative. Well, the derivative is this. And when I plug in minus 2, I get a negative number. So the slopes to the left of minus 1 are negative, 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 right?
Right.
If I plug in 0, I get a positive number. And 0 is to the right of minus 1. So in other words, I've got something that looks like this. And there's minus 1, and the slopes are negative, negative, negative leading up to it, and they come out of it positive, positive, positive. That means it's a minimum, not a maximum. So that tells me that negative 1 is the minimum. If I did the same test about positive 1, I would find that it went from positive, positive, positive to negative, negative, negative. And I happen to draw this or plot this curve. This is what it looks like on Wolfram Alpha. You can see where I have a minimum at negative 1 and I have a maximum at positive 1. You can also see that to the left of negative 1, my slopes are negative. To the right of negative 1, my slopes are positive. That's how I know minimum, not a maximum. The maximum goes from plus, plus, plus to minus, minus, minus. So there's a first derivative test and there's also a second derivative test. If you can easily take the second derivative, then is all you need to say is, well, the second derivative is going to be concave up, meaning positive, So if I took the second derivative of this function, plugged in -1, I would get a positive number. If I took the second derivative of it and plugged in +1, I would get a negative number because that's concave down. Concave down goes with negative, concave up goes with positive. And occasionally you take the second derivative and you'll get 0, okay, which tells you nothing. When you take the second derivative and get 0, then you have to go back and try the first derivative test. You have to test to the left and to the right. See whether you're going negative, negative, positive, positive, or positive, positive, negative, negative. So there's 2 tests to determine whether it's a min or a max. And clearly on this one, the minimum occurs at x equal -1, and the minimum value, if you plug in x equal -1 into the original function, you get -3/2.
Yes.
And you definitely want to plug it into the original function, not the derivative function.
Right. Right.
Because that's what, in other words, if I go back and I look at this curve that I have here, if I want to know what the minimum value is, this is the original function here. Well, if I plug in x equal -1, I get -1.5. It's actually -3/2. And that's what you wrote, was -3/2.
Okay.
All right, that was 11 and 13. I think I have 14 also. You want to go over it?
We already went over 14.
Okay. That was the second page? I thought I pulled it up.
Right.
I didn't recognize it. Hold on a minute. I don't remember going over this one.
No, I have work.
Yes, I do. Yeah, you're right. And it was, I think it was C was the answer, wasn't it?
Yeah.
Yeah, again, this is fairly easy. You just take the derivative, and wherever the derivative is positive, the original function is increasing. Wherever the derivative is negative, the original function is decreasing.
Yep. Okay.
Anything we haven't gone over of these 4 pages?
I think that covers it all.
Okay.
I'm comfortable with everything else.
Okay, cool. And
those were just the ones I had questions on.
Good. And again, my apologies. Try not to ever let that happen again. It's not just that I was 15 minutes late, it's that I was coming out of a nap, and trying to do calculus is hard when your brain is foggy like that.
Oh no, I've done it too. I've definitely had my fair share of
Yeah, that's not the
late
time.
moments.
You don't want to take a nap before a calculus test.
Right.
At least not immediately before it. All right, Matthew, you go. Hope your haircut came out okay. I'll talk to you.
Well, meh.
We'll talk to you.
All right, talk to you later.
All right, bye-bye.
Thanks so much.